A wire AB of length L, mass M, and resistance R slides on a smooth, thick pair of metallic rails joined at the bottom as shown in figure. The plane of the rails make an angle theta with the horizontal. A vertical magnetic field B exists in the region. Now if the wire slide on the rail at a constant speed V, we have to show this expression. Now take this view of the figure. We have an inclined plane with an angle theta. The wire AB is this one, so the direction of magnetic field is straight upward. Now let's say that velocity is in this direction, so we have V cos of theta, V sin of theta, mg force acting straight downward, and again taking component we have this angle as mg sin of theta. Now proceeding, we had to first calculate the EMF induced due to the motion of the rod AB. So it will be equal to B into V into L. Here B is the magnetic field, no problem. This velocity has to be perpendicular to the direction of the magnetic field. So we took the component of V as V sin theta and V cos theta, and V cos theta is perpendicular to magnetic field. So here V will be V cos of theta into L. This is the EMF. So current flowing through the wire AB will be calculated by Ohm's law, that is E by R. We get B V L cos theta divided by R. Now force, that is the magnetic force on the wire due to the current flowing in it, can be calculated by the formula B I L, and again the direction of the force will be in this direction. This force is the magnetic force. The direction can be easily calculated because the current is flowing in inside direction and the magnetic field is upward. So the force will be ideal cross B, which is right hand side. So BIL, now substituting the value, we have B, current is BVL by R cos theta into L, which comes out to be B square L square V cos of theta divided by R. Now since the velocity is constant, that is V, therefore the net force acting on the wire AB has to be constant. So this magnetic force F magnetic has to be equated with the mg force acting on the wire. Now resolving the component again, we have this angle as theta, so this factor gives me F magnetic cos of theta, and this gives me Fmg sin of theta. Now F magnetic sin of theta will be equal to, or I must write F magnetic cos of theta will be equal to mg sin of theta, so that net force along the inclined plane will be 0 and the wire will move with a constant speed v. So substituting the value, we have F magnetic as b square L square v cos theta by r into cos theta is equal to mg sin of theta. We have b square L square v cos square theta is equal to mg r sin of theta. So b comes out to be mgr sin of theta divided by L square into v cos square theta to the power 1/2. That is the answer.